It's a pleasure being here, and this kind of event is what UFRO is about. So it's really nice to do this kind of information sharing. And since I'm the one first up for the presentations, I've also tried to put myself on a level that is not well, it's adapted for those who are not very familiar to the Nordic conditions and what kind of things we do in our normal practices, which is quite high tech and futuristic for many corners of the world. And then I will also kind of lay the floor for Kalle, who will go more, I assume, go more into details on what is going on with examples from projects in Finland and such. And also see in the participant list that we have excellent experts in this field from other corners of the world too. So I think you can also chip in when we come to the discussions if you think that things are missing. So I will start with telling you, kind of start with the basics, just to kind of lay the ground here, because forest operations, if you look at it from one perspective, it's very simple things that we are trying to do. In all the corners of the world, we want to transform a tree into logs or something similar, depending on what kind of process we are looking at. But yet, if you travel the world, there is so fantastic many different variations of how these things are done, what kind of equipment you can see to do basically the same thing that is happening. And that is because these processes are done in a raster, in a layer of what is actually logic and what is available in the local conditions in terms of the environment and the social rules and what kind of machinery and other kind of things you have there. So that is a reason for why there is so many differences. So that's why I also want to lay the ground to tell you, for those who are not very familiar with the Nordic conditions, we use very much the rotation forestry, but we have a very long rotation compared to many other parts of the world. And just to have a round number, we normally say 100 years. In the presentations, you will see different numbers, but about 100 years it takes from establishment to the final harvest. And the processes we are doing, it is to do some kind of site preparation and scarification. But Thomas Ersson will tell you more about these things. We do planting and to some small extent sowing, but it's normally planting. We also do some kind of pre-commercial thinning to take away some of the smaller trees. We don't use that, the trees, we just remove them. And then later on, we do thinnings in which we also use the logs. And that can be from 1 to 3 times depending on where you are in the country. And then it's a final felling, a clear cut, and then it starts over again. So that's kind of the general process here. And these things are done, if you look at this in a more generalized view, this is done with the use of energy, some kind of apparatuses, machines or such, and you have information. And just to show the kind of variation there is, even if in very advanced forestry areas, I want to talk you through about what we have in Sweden. And as you noticed, we have completely manual operations. The planting is predominantly done completely manually and has been done so since very long time. So here is a human that is giving the energy. It's a human who is also providing the information, and there is some kind of tools used. We also have motor manual operations, and that is a pre-commercial thinning. And then you have the energy from both the human and the machine, and the human is providing the information. And then we have the major part of the harvesting is, of course, done with machines, quite advanced machines also. So then you go to fully mechanized operations with the apparatuses being machines that are carrying the humans, and the information is the only thing that the human is providing. And the machine is providing more and more of this information, which we will see examples of later on. And what is emerging more and more, that are the 2 last steps, and that is semi-autonomous mechanized operations, when the information is more and more provided by the machine. The machine can do certain things by itself, and the human is complementing with some of the information provision. And then the last part, that is kind of the holy grail that is emerging more and more, the robotics and such things, when you have fully autonomous operations, when the machine is providing all of the things needed to do the actual work process. And there is a picture of a platform we have in my research group that is able to do these kind of work in a very simple conditions, but still fully able to find and load logs autonomously. Far from being operational, but still there are examples of this being able to be performed. But going back to the actual operations then, what are we doing? Well, we are using the mechanized cut length operations. And an important part here is to understand that this is done year around in the Nordics. And there is huge variations. As I put here, there is both times when there is nice and green conditions, and then you have those times of the year when it's almost always dark and a lot of snow and very cold. But nevertheless, the operation is conducted all year round. It's done by contractors, which means that there is small companies, small in the sense that there are few people and they are owning some machines, 1, 2, 3, 4 machines, but not very many. But the machines, on the other hand, are very expensive and very advanced. They are doing the work, all of it basically. They are giving instructions, but then they are selecting the trees. They are taking care of most of the silvicultural decisions and such. So the contractors are not just machine operators. They are also actually foresters in the way that they are doing the practical forestry decisions. And the price model is so that the contractors are normally paid for the work that they are done. So they are paid for the volume, for instance, they are delivered at roadside. So they have incentives to be highly productive and cost efficient. And then we come to the machinery itself. They are highly advanced. So the harvesters are normally transforming about 2 trees per minute, depending on the tree size, but they are harvesting 2 trees per minute continuously, and they might work for up to 16 hours per day. So that is a very highly high work rate in that sense. And the forwarders are quite big. The payload is normally now for final felling is about 20 tons or even more per load. So that is also very big machines and highly productive in that way. They are very computerized. It's a lot of computer systems, especially in the harvesters. There is online communication to and from the machine for automatic delivery of the information and data. And since very long, we have had the system of an optimized way to do the bucking, to cut the trees into logs, to do value optimization. And this has been around since the 1980s. It's not called AI, but if it would have happened now, it would definitely be labeled as an AI application. Then we go to the road transports, and then we have these kind of trucks. And they are both very long for being in Europe, and they are also allowed to carry very high loads, and it is now even more than 60 tons per truck. It's quite a bit of load that they can have. So the payload is normally more than 40 tons that can be delivered in more or less a normal road network. And here the system is the same as the pricing is the same as similar as for the harvester and the forwarder contractors. It's an incentive system, so they are paid per ton and kilometer of transported logs. You can also see that many of the trucks are having cranes, so they can load themselves. They go to the forest and they load themselves, and then they go to the industry and it's unloaded there. And they're also having computers on board, not as advanced as the harvesters, for instance, but they are having onboard computers for the management of the wood flow and the information of where to go and those kind of things. So that is kind of the standard normal system with the machines and so on. And then I will touch slightly upon something that is not as often touched upon when we talk about forest operations, and that is the measuring and the reporting, especially in Sweden. We have a system since very long back with an organization that nowadays is called Biometria, and it's an impartial organization. It's a ownership, shared ownership between forest owners and industries, and they are responsible for the collection and the distribution of data from all the parts of the process. And they're also responsible for the measuring and the pricing and the financial kind of background for the businesses between the one who is selling and the one that is buying wood. And this is done according to a standardized system. So wherever you are in Sweden, you can sell wood with different partners and in a standardized system, which is facilitating very much here because you can do changes between industries. You can deliver to one industry and you can get wood back with your other industry in another part of the country, etc. So it's a lot of good things happening because of this system, which is normally not touched upon so much. And just to give you an extent, I think these numbers are a little bit old now, but it's a huge network of different organizations and units involved in this. So there is, for instance, most of the harvesters and the forwarders are connected automatically to this system and delivering data. Same thing with trucks and all the receptions points. So that is the industries that are receiving the logs eventually. And this gives a very good possibility also for supply chain management. So there are at least daily reports of what the production is from the different harvesters and the forwarders and the trucks, etc. So there is easy access to knowing how much logs is in the forest, what is the forest stock on the way to the industry. And also after the forwarder has done the delivery to the roadside, there is information of that. So you know the roadside stock. And the manager can also know how much is on the truck. So they actually have a understanding of how much is a rolling stock, what is on the way to the industries, etc. And on average, we in Sweden keep about 2 weeks of roadside stock. So that is what kind of is lying around on average, and then there is seasonal differences and variations, of course. So this is a pretty intricate, very advanced supply chain management possibility that is used and in place for the everyday business. And then we come to what is happening actually now, and I will kind of lay the ground, and then I'm quite sure that Kalle will go more into details here. And we can see 3 different, or actually 4 different steps, and if you group them in this way. And one thing is to get more data of basically everything in the forest environment, and this is done on very large scale. And one of the best examples of that is the laser scanning of the forests with more and more accuracy, more and more points per square meter, etc. And that is to get more information. And then the things that are coming out of it, for instance, elevation maps. Now we start to have really good understanding of our forests, how high are the trees, where are the trees, etc. It's also used to produce depth of water map to understand where are the moist areas, where is this challenges in terms of bearing capacity, where should we not drive, etc. The terrain models I already told you about, but it's also going down to actually see individual rocks, individual lying trees, and all these kind of things, and seeing the individual tree maps, etc. This is then used to get decision support tools to transform the data to some kind of useful information. I'll tell you a little bit more about that. And the last step is the automation. And the automation is, of course, depending on the 2 previous steps, that you need data, you need decision support tools. Another thing that is also ongoing in parallel, I would say, and that I will not tell you very much about, but that is electrification. That's a clear track also what is happening. So there is a lot of efforts going on from manufacturers mainly to make the forest machines and the timber trucks electrified. And we are part of the CIFO project, as you see there, and then there is that is focusing on making the forest machines electrified. And I have a PhD student, for instance, studying the interesting challenge of how to get the energy to the forest if it's not going to be diesel. How can you supply the electric machine with the energy? It's not close to the grid, etc. And similar things are happening, and even faster progressing, I would say, with the transition to electrified forestry timber trucks to do the road transport electrified. So here are some examples of decision support tools that are already used, and there are tools that are used to follow up work in terms of how thinnings have been done, both in terms of how much should be thinned in different areas, not just taking an area and saying to the operator, do exactly the same thing everywhere, and then they can adapt. But now it's possible to do more detailed maps about what kind of thinning should be done in different places, depending on how the trees has grown as a response to variation within the stand, to do a little bit less thinning in one area and do more in another thinning, and then it can also be followed up and supported during the actual thinning operation. So the operator has in real time information about how much has been removed and how much should be continuously removed, or if it is okay as it is. We have for extraction, there is good decision support in the machines in terms of maps showing where the moist areas are. The depth to water maps are more or less standard in the machines now to have that as an information about where it is risk for being damages to the soil if they drive there. And there is also tools for helping do the planning of the network itself, how to drive, where the driving should be done in the best way. And if you go to the transport of the road transport, it's the same thing there. There is tools for planning both what industry the delivery should be done to be the best cost-efficient way, but also to find the shortest way to do the most efficient driving with the timber trucks during a day to get the maximum transportation capacity out of each truck. And there is many more examples also, but the main thing is here that they are helping the operator, and this is interactions that is done more or less in real time for most of those applications. So this is definitely helping the operators that is existing right now. But the interesting thing is, of course, also that it's also laying the ground for the automation part, which we will come back to. Another example is a project for those of you who was listening to the first seminar. I'm quite sure that Mauricio Acuna was telling about the Opti4Value project. It's a European project in which there are focus on also decision support things, like, for instance, I highlighted two things here, and that is early warning indicators, that there is informational, they are aiming to have early warnings about trees that are starting to get ill, or that wood quality might deteriorate. And there is also focus on improving the agility, the flexibility of the operational capacity. And that could be, for instance, to know when roads are good to drive on and when they are not good to drive on, not just based on their road class, like the standard road class, but also depending on the actual weather and the weather forecast. So you know that, yeah, the road is a certain class, but because the weather will be unusually good or unusually bad, you know that you have a better or worse possibility to use that road for a certain time period in the future. So that is part of a bigger project also that is aiming to do more of these decision support systems. And then we come to the automation part, the more kind of futuristic and the most mind-tickling things. And then there is a lot of things going on worldwide, I would say, about especially to move around in the forest. There's a lot of things going on the decisions that need to be made also, but I just focus here on the locomotion parts. And you have all of these quadruple robots that are walking around like dogs, and there is more and more sensors integrated. The one on the left there, that is now integrating many different sensors, also those who can actually feel the surface when it's moving around. And you have flying sensors that are able to fly in 20 kilometers per hour in dense forest without colliding with things. You have the deep robotics robot that is a mixture between a four-legged and wheeled walking combination there. And then you have, I saw that Richard Parker is with us here in the meeting also, and this I really love his idea with the climbing robot, just to get away from the ground but not flying. So that is also something that is also intriguing with different kind of locomotion principles. And then last but not least, of course, all of the initiatives that is relating to flying machines, different kind of drones of different sizes. And here is an example from a really big one in Sweden from a company called Air Forestry, which are aiming to do harvest from the top with a drone like that, to be able to harvest and pick up a debranched tree and bring it to roadside. And then we come to the few projects, or not the few projects, but the projects that are actually aiming to do some kind of work that we in Forestry Operations can relate to also, not just moving around, but also do something. Then there is, of course, much less projects. I put some examples here, and that one is the one, those two were presented in the UFO World Congress a couple of years ago in Stockholm. And one is a concept machine for planting. So back Thomas will come back to that one. And the lower one, that is, as I told you, that is from my research group, in which we are able to do autonomous forwarding. Not very fast, but completely without our interaction. So the machine can find and do the whole work all by itself. So there are those kind of things happening, but it's of course much less activities, because it's very few people focusing on this. For the moving around in the forest, etc., that is much more people, of course. So I will not go much further into depth with this, because I think I already used up much of my time, but I will lay the ground like this to kind of let Kalle continue. And then I will just end by saying that, well, the future will for sure have much more AI and robots and human interactions, because the whole society is going so rapidly to that. So it would be very strange if it wouldn't be that in forestry. But there will also be very big mix, I'm quite sure, between all the different kind of systems, because the conditions are so different around the world. So the operations will be different. And what is most important, I kind of encourage people to start to think about, why should we do this? Technology is nice, but there should always be a reason for doing the change, not just because it's cool with the new technologies. So always keep that in mind. Is it doing something better when we are replacing or transferring to something, or are we responding to some kind of a need to change? And why are we doing that in that sense? But it's going to be a very interesting future. So with that, I thank you for the attention.
Thank you,